Hi, my name is Mr. Kangas, and today we're going to be taking a look at Chapter 8, Section 2, solving equations with grouping symbols. And in particular today, we're going to be taking a look at equations that have no solution at all, and equations that have all numbers as a solution. It's really important as we go through this section that you keep in mind what that equal sign means. That equal sign is telling us that both sides have to be exactly the same. I can't just throw up any random numbers that I want on both sides of the equal sign. I can't say that 3 equals 5 and say that's a true equation. That's a false equation. And there are other types of false equations that include variables. And so those equations are considered to have no solution because they are untrue. It's a false statement. So we're going to take a look at one of those equations right now. We have 3x plus 2 equals 3x plus 4. It is impossible for this equation to have a solution if you just take a look at it. The variables are the same. We have 3x on both sides. But the number that is not connected to the variable is different for both of them. So it doesn't matter what number I plug in for x, because remember, x is the variable. X is what can change about this equation. So that's typically where you have a little bit of leeway to make these equations equal to each other, or make these expressions equal to each other. But the fact that both expressions on both sides of the equation have the same variable, that means their variable, no matter what number I plug in, is going to get them the same answer, because whatever I plug in for x on the left side, I have to plug in for x on the right side. So I'm going to end up getting the same answer, no matter what. I'm going to get 6 in place of 3x on the left and the right side. And 6 plus 2 is 8, 6 plus 4 is 10. Because this number is different for both of these, and the variables are exactly the same, I'm not going to be able to get a solution here. Now, if this 3 had been changed to a 4, now suddenly it's a different ballgame, because my variables aren't going to necessarily yield me the same answer. So it's going to be possible for there to be a number. Not any number I want, but there will be a number out there that would make this equation true. Because now suddenly I can get a different answer. Even though I'm plugging in the same number for x, because the number next to the x is different, I'm going to get a different answer on both sides of the equation. Which will allow me to get the same answer on both sides when I solve the expression in completion. When I fully solve it, when I add the 2 afterwards and add the 4 afterwards. But if the variables are going to get me the same answer because they both have the same coefficient, then it's impossible to get the same answer on both sides. Because you can't add 2 to 6 and add 4 to 6 and get the same answer. That's essentially what you're thinking about here. When you see 3x and 3x here, you just replace that 3x with any old number. Let's say it's 5. Okay? I can't add 2 to 5 and 4 to 5 and get the same answer. It's impossible. Never will happen. And this situation is going to come up no matter what number I plug in for x. I could plug in 1, I could plug in 4.3, I could plug in 720. I'm going to get the same answer here and here every single time. Now, there are also equations that get you all numbers for a solution. That means you can plug in anything you want and it'll be true. For example, if the same thing is on both sides, you see the same exact numbers, same exact variables, same exact operations, then every single number in the world will work. I can plug in 2 here, I better get the same answer that I do over here as well. If I plug in 4 here, I'm going to get the same answer as I do here. If I plug in 0.3 here and 0.3 here, I'm going to get the same answer on both sides. negative 32, I'm going to get the same answer on both sides because the same exact expression is on both sides. So if you have an equation where the same exact numbers, variables, and operations are on both sides, then you're going to get the same answer. Now, sometimes you may not realize that you have an all numbers solution for your equation because you have to remember with addition, we can flip-flop things. So sometimes you may see 3x plus 2 equals 2 plus 3x. This is still an all solutions equation because you still have 3x, it's still being added to 2. You have to remember your commutative property rules that these numbers can be flip-flopped, and that's okay. You're still going to get the same answer. The other thing you might see is you might see 6x plus 4 equals 2, 3x plus 2. This will also get you an all numbers solution for your answer where any number works for x, but you have to remember that this is unsimplified. Okay? So if we simplify this, you'll see that this will actually get me 6x plus 4. To get rid of those parentheses, I need to use distributive property here. 2 times 3x gets you 6x. 2 times 2 gets you 4. We keep the sign in the middle. And as you can see, I have the same thing on both sides. So if the same exact looking equation is on both sides, all numbers is the solution. That's all there really is in this section. Like I said, there are a couple of situations where you run into all numbers as a solution for your variable, and there's a couple situations where you're running as nothing, no solution for your variable.